Hey everyone, welcome back to the channel. Today we're doing something really interesting. We're diving deep into the world of advanced AI models. You know, the kind that powers everything from your smart assistant to those crazy, realistic deepfakes. Now you might be thinking AI models sounds kinda technical, MKBHD. And you'd be right, but trust me on this one. These models are a big deal because they're about to change the way we interact with technology in a major way. Especially in a field I'm super passionate about, healthcare. We've got 5 heavy hitters in the ring today: Tulu R 405B, DeepSeek R1, Lama 3.1, OpenAI 4001, and Google's rumored beast, Gemini 2.0. Each one brings its own strengths and weaknesses to the table, and today, we're gonna break down their specs, their performance, and most importantly, their potential impact on the future of healthcare. So, buckle up, hit that subscribe button if you haven't already, and let's get this AI showdown started. First up, we have Tulu R 405B. This isn't just any AI model, it's a groundbreaking leap in artificial intelligence technology. Now, the name might sound like something out of a sci-fi movie, but this thing is the real deal. Imagine the most advanced AI you've ever seen in a film, and then take it up a notch. We're talking 405 billion parameters. Yes, you heard that right, 405 billion. That's an astronomical number, representing the sheer complexity and capability of this AI. That's like the entire population of the US times 4, all working together inside this one AI model. Imagine the collective intelligence and processing power of such a massive group, all focused on solving problems. It's designed to crunch massive data sets, and I mean truly massive. We're talking about data that would take traditional systems years to process, handled in a fraction of the time. Think medical records, research papers, you name it. The Tulu R 405B can sift through these vast amounts of information with ease, identifying patterns and insights that would be impossible for humans to find. This thing can handle it. No matter how large or complex the dataset, Tulu R 405B is up to the task, making it an invaluable tool for researchers and data scientists. It's like the supercomputer of language models, built to tackle the most complex problems in natural language processing. Whether it's understanding context, generating human-like text, or translating languages, this AI excels. And when it comes to performance, Tulu R 405B doesn't disappoint. It sets new benchmarks in speed, accuracy, and efficiency, outperforming previous models by a significant margin. It's incredibly strong in natural language inference, basically understanding the relationships between words and sentences. This makes it perfect for applications like chatbots, virtual assistants, and automated customer service. This is huge for things like analyzing medical literature and drawing conclusions from research data. But there's a catch. With great power comes great responsibility, and in this case, great resource demands. This kind of power comes at a cost. The computational resources required to run Tulu R 405B are immense, and so is the energy consumption. We're talking serious computational resources. You need a robust infrastructure to support this AI, including high-performance servers and advanced cooling systems. To run this thing effectively, you need top-of-the-line hardware. We're talking about the best of the best in computing technology, which can be quite an investment. It's not exactly something you can run on your smartphone, at least not yet. But who knows what the future holds? With advancements in technology, we might one day see this level of AI power in the palm of our hands. Next up, we have DeepSeek R1. Now, DeepSeek takes a different approach compared to Tulu. While Tulu is all about brute force parameter count, DeepSeek is more about strategy, using something called reinforcement learning. Think of it like this. Tulu is the weightlifter, pure power, while DeepSeek is the chess player, making strategic moves. It might not have as many parameters, but it's designed to be incredibly efficient at finding and connecting information. This is where DeepSeek really shines: active knowledge hunting. Imagine you're a doctor with a really complex case. You need to pull information from medical journals, patient histories, even genetic databases. DeepSeek can navigate all of that and pull out the exact information you need, like a superpowered research assistant. But this approach isn't without its quirks. DeepSeek can sometimes be a bit slower to give you an answer, especially if your question is a bit vague. It's like it wants to double-check its work, cross-referencing everything, before it gives you a definitive answer. Alright, so we've talked about Tulu and DeepSeek, two very different approaches to AI with their own strengths. Now let's shift gears and talk about speed. When you think about AI that needs to be snappy and responsive, you're thinking about models like Llama 3.1. This one's all about efficiency. It might not have the billions and billions of parameters of the bigger models, but it's built on a super streamlined architecture. Think of it like this. Tulu and DeepSeek are like giant, powerful trucks. They can haul a lot, but they're not winning any races. Lama, on the other hand, is like a sports car. It's nimble, it's optimized for performance, and it can give you those near-instant responses that are so crucial for certain applications. This is where those low latency times really come into play. We're talking chatbots that feel like you're actually having a back and forth, or AI assistants that can keep up with your workflow in real time. These are the situations where Llama really shines. OpenAI has been on a roll, and 4001 is their latest and greatest. This new model represents a significant leap forward in the world of artificial intelligence, building on the solid foundation laid by its predecessors. You've probably heard of GPT. It's like the foundation for a lot of AI language stuff these days. GPT, or Generative Pre-trained Transformer, has revolutionized how we interact with machines, making them more capable of understanding and generating human-like text. Well, 4001 takes that GPT base and cranks things up. It's not just an incremental improvement, it's a game-changer in many respects. We're talking about a model that's been trained on a massive dataset of text and code. This extensive training allows it to understand and generate text with a level of sophistication that's truly impressive. This thing has seen it all, from Shakespearean sonnets to complex code for machine learning algorithms. Its training data spans a wide range of topics and styles, making it incredibly versatile. What's impressive is how OpenAI keeps pushing the boundaries of what these models can do. They are constantly innovating, finding new ways to make their models more powerful and efficient. They're not just about bigger and more powerful, but also smarter and more efficient. This means that 4001 can perform complex tasks without requiring an enormous amount of computational resources. 4001 is a testament to that. It's not just about brute force processing, it's about understanding context and nuance. This makes it incredibly effective at tasks that require a deep understanding of language. One area where 4001 really shines is in its ability to generate human-quality text. Whether it's writing an article, creating a story, or drafting a report, the text it produces is often indistinguishable from something written by a human. We're not just talking about basic sentences here. I'm talking about creative writing, technical documentation, even poetry. The range of its capabilities is truly astounding. It's pretty wild to see how far this technology has come, and 4001 is a glimpse into the future of what AI can do with language. Imagine a world where machines can understand and generate text as well as, if not better than, humans. So, what makes 4001 so special? It's the culmination of years of research and development, bringing together the best of what OpenAI has learned over the years. Well, it's a bit of a jack of all trades when it comes to language. It can handle a wide variety of tasks with ease, making it incredibly versatile. It can hold a conversation like a champ, whether you're chatting about the latest tech news or debating the finer points of quantum physics. Its ability to understand and generate text in different contexts is truly remarkable. It's also a beast at content creation. Whether you need a blog post, an article, or even a script, 4001 can handle it with ease. Need to write a blog post about the history of AI? No problem. 4001 can whip that up in a flash, providing you with well-researched and coherent content. 4001 can whip that up in a flash. Its ability to generate content quickly and accurately is one of its standout features. How about a script for a YouTube video? Yep, it can handle that too. From drafting the script to suggesting edits, 4001 makes the process seamless. Yep, it can handle that too. Its versatility in content creation is truly impressive. And don't even get me started on text analysis. 4001 can dissect a research paper, summarize a news article, or even translate languages with remarkable accuracy. Its ability to understand and process complex information is unparalleled. 4001 can dissect a research paper, summarize a news article, or even translate languages with remarkable accuracy. Its ability to understand and process complex information is unparalleled. This makes it an invaluable tool for researchers, writers, and anyone who needs to work with large amounts of text. Alright, now let's talk about Gemini 2.0. This is Google's not-so-secret weapon in the AI arms race. The tech giant has been investing heavily in artificial intelligence, and Gemini 2.0 is the culmination of years of research and development. It's a testament to Google's commitment to pushing the boundaries of what's possible with AI. We've been hearing whispers about this one for a while, and the rumors alone are enough to get excited. The anticipation has been building, and now that it's finally here, the excitement is palpable. Industry insiders have been speculating about its capabilities, and the buzz has been nothing short of electric. You see, Gemini is designed from the ground up to be multimodal. This means it can handle a variety of data types simultaneously, making it incredibly versatile. It's not just a language model, it's a comprehensive AI system that can process and understand text, images, audio, and potentially even more. What does multimodal even mean? In simple terms, it refers to the ability to process and integrate information from multiple sources. For example, a multimodal AI can read a text, analyze an image, and listen to an audio clip, all at the same time, and then combine that information to provide a more comprehensive understanding. Well, it means that unlike most language models that just focus on text, Gemini can understand and process different types of data. This is a significant advancement because it allows the AI to draw connections between different types of information, leading to more accurate and insightful responses. We're talking text, images, and maybe even audio all rolled into one. This multimodal capability is what sets Gemini apart from other AI models. It can analyze a piece of text, recognize objects in an image, and understand spoken words, all within the same framework, and maybe even audio all rolled into one. Imagine the possibilities this opens up. For instance, an AI that can listen to a podcast, read the accompanying transcript, and analyze the images discussed in the podcast all at once. This level of integration is unprecedented and could revolutionize how we interact with AI. This is a big deal because it opens up a whole new world of possibilities for AI applications. From healthcare to education, the potential uses for a multimodal AI are vast. In healthcare, for example, Gemini could analyze medical images, read patient records, and listen to doctor-patient interactions to provide a more accurate diagnosis. Imagine an AI that can not only read a recipe, but also show you what each step should look like, and even play an audio clip explaining the process. This would make cooking much easier and more accessible, especially for beginners. Or a chatbot that can understand the emotions conveyed in an image you send. This could lead to more empathetic and effective customer service interactions, as the AI would be able to gauge the user's emotional state and respond accordingly. But what really sets Gemini apart is its ability to switch contexts seamlessly between these different data types. This means it can move from analyzing text to interpreting an image without missing a beat, providing a more fluid and natural interaction. Think about how we, as humans, process information. We constantly switch between different types of data, like reading a book while listening to music or looking at a picture while talking to someone. This ability to multitask and integrate information from various sources is what makes us so effective at understanding the world around us. We don't just see a picture and then read some text in isolation. We connect the two, drawing meaning and understanding from the relationship between them. This integrated approach is what Gemini aims to replicate. We connect the two, drawing meaning and understanding from the relationship between them. This is crucial for tasks that require a deep understanding of context, such as summarizing a news article that includes both text and images. That's the kind of fluidity that Gemini is aiming for. It's designed to provide a seamless experience where the user can interact with the AI in a natural and intuitive way, regardless of the type of data being used. It's not just about understanding different data types in isolation, but about seeing the connections and relationships between them. This holistic approach allows Gemini to provide more accurate and meaningful responses, but about seeing the connections and relationships between them. This interconnected understanding is what makes Gemini so powerful. It can draw on its knowledge of different data types to provide a more comprehensive and nuanced response. This is what allows Gemini to provide richer, more nuanced responses. Whether it's answering a complex question or providing a detailed analysis, Gemini's multimodal capabilities enable it to deliver more accurate and insightful information. For example, you could show Gemini a picture of a historical event and ask it to write a caption, and it would be able to draw upon its vast knowledge of history, language, and visual understanding to provide a truly insightful and accurate description. This could be incredibly useful for educational purposes, as it would allow students to gain a deeper understanding of historical events. And it would be able to draw upon its vast knowledge of history, language, and visual understanding to provide a truly insightful and accurate description. This level of understanding is what sets Gemini apart from other AI models. Now, building a multimodal AI like Gemini is no easy feat. It requires a deep understanding of various data types and how they interact with each other. The development process involves a lot of trial and error, as well as continuous learning and improvement. It's a massive undertaking that requires specialized hardware, advanced algorithms, and a whole lot of data. The hardware needs to be powerful enough to handle the complex computations required for multimodal processing, while the algorithms need to be sophisticated enough to integrate and analyze different types of data, and a whole lot of data. The data used to train Gemini comes from a variety of sources, including text, images, and audio. This diverse dataset is crucial for teaching the AI how to understand and integrate different types of information. One of the biggest challenges is training a model that can effectively handle the complexity of multiple data types. This involves not only feeding the AI vast amounts of data, but also fine-tuning the algorithms to ensure they can accurately process and integrate this information. It's one thing to train a model on text data, which is relatively straightforward, but it's a whole other ballgame when you start throwing images, audio, and potentially even sensor data into the mix. Each type of data presents its own unique challenges and requires specialized techniques to process effectively. But it's a whole other ballgame when you start throwing images, audio, and potentially even sensor data into the mix. This requires a deep understanding of each data type and how they can be integrated to provide a cohesive understanding, and potentially even sensor data into the mix. Sensor data, for example, can provide real-time information about the environment, which can be incredibly useful for applications like autonomous driving or smart home systems. This requires massive amounts of computational power and sophisticated training techniques to ensure the model can learn the intricate relationships between these different data modalities. The computational power needed for this is immense, often requiring supercomputers and specialized hardware to handle the load. And let's not forget about deployment. Once the model is trained, it needs to be deployed in a way that allows it to function effectively in real-world scenarios. This involves setting up the necessary infrastructure and ensuring the AI can handle the demands of real-time processing. Running a model like Gemini is not like running your average app. It requires specialized hardware and infrastructure to handle the sheer volume of data and processing power required. This includes high-performance servers, advanced networking equipment, and robust data storage solutions. It requires specialized hardware and infrastructure to handle the sheer volume of data and processing power required. This means that only organizations with significant resources will be able to run Gemini effectively, at least in the early stages. This means that access to Gemini, at least initially, will likely be limited to those with the resources to run it. However, as technology advances and becomes more accessible, we can expect to see more widespread adoption of multimodal AI systems like Gemini. That's it for today's AI Showdown. We've covered a lot of ground, from the massive scale of Tulu R 405B to the multimodal capabilities of Gemini 2.0. Each of these models represents a significant step forward in the world of AI, and they all have the potential to revolutionize different industries. Host, that's it for today's AI Showdown. Do you agree with my take on Tulu R 405B, DeepSeek R1, Lama 3.1, OpenAI 4001, or Gemini 2.0? Let me know in the comments which model you think will have the biggest impact on healthcare. If you found this video useful, give it a thumbs up and subscribe for more tech deep dives. Thanks for watching, and I'll see you in the next video.